Hi, my name is Manuel de la Rosa, and my main goal in this session is to explain why a strategy works, a game strategy. So because this is a game strategy, what I'm going to do now is I'm going to present a game, right? I will explain the game. Then I want you to think about if we can find a strategy to win the game, and then we will analyze if the strategy, if it exists, works, or it doesn't work. And we will try to give a solid argument why it works. So, right, let me go straight to the game, right? So you have three doors, 1, 2, and 3, and behind of one of these doors, there is a car, which is the prize. So, I will ask you, could you please pick a door? So for the sake of the argument, you say, well, number 1. So you pick door number 1. Now, because I am the host, and I know where the car is, I will open one of the other 2 doors. So I will open number 2, and you will see there is no car. So now the question that I'm going to ask you is, do you want to change, or do you want to keep your first choice? One more time. 3 doors, there is a car only in one door or behind one door, and then you pick one, you pick number 1, you could pick number 3, number 2, doesn't matter, you pick one of the doors. After picking one of these doors, I open the door where I know there isn't any car, which is number 2, and then the question is, do you want to change, or do you want to keep with your door? What would you do? Would you change? Would you keep? And more important than what would you do is, does it matter? Does it really matter to change? In terms of my chances, in terms of probability, does it matter to change? Now, let's go to work in pairs, right? What about you two, you two, you two? And then only 5 minutes. In 5 minutes, could you decide, number 1, if you want to change or if you want to keep the door, and why? Do we have a strategy? Does it matter to change or not? So I'm going to give you 5 minutes. Could you please work in pairs and discuss it? Okay, 5 minutes passed. Now, most of you, this is the first time. Well, let's see if we have some answers. Yeah, over there. Yeah, Peter, right? Okay, do you have an answer? Okay. Right, could you come and explain it, please? Okay. So now, suppose I am Peter, and I will say the following. Oh, teacher, it doesn't matter, because look, we have 1 car and 3 doors. So we only have 1/3 at the beginning. So at the beginning, we have only 1/3, 1/3, 1/3. So my chances to pick this door is 1/3. My chances that the car is behind this door is 1/3. When you remove this one, I only have this one. But the chances for this door is also 1/3. So it's 1/3 and 1/3, the same chances. It doesn't matter if you keep this door or you interchange with this one. Then I will ask if Peter is here. Okay, but you are not really taking into consideration when I remove this one. Because when I remove this one, you don't have 3 anymore. You only have 2. So the usual answer that a student gives is the following. Okay, I think it doesn't matter anyway, because when you remove it, yes, you, teacher, are right. Sorry, you, teacher, you're right, because you only have 2, so my probabilities are not the same. I only have 2 and 1 prize, so it's 1/2. So this is 1/2 and this is 1/2. But in this case, if I pick this one or if I pick this one, again, it doesn't matter. I have 50 and 50. So, me as teacher, I will say, okay, Peter, thank you very much. Go to your classroom and I will ask, okay, class, what do you think? Now we will listen some opinions and then I will say, okay, well, let me tell you something. Let me tell you very briefly a little story. This problem was posed many years ago by Marilyn Faux-Savant. Faux-Savant. She she posts this magazine, this problem in a magazine. Now you go at the end of the magazine, you have some teasers and some quizzes. She posts this problem, and people respond. The typical problem was, it doesn't matter, it's 1/3 or 50 and 50. But in both cases, you have the same chances, the same probability. Right. Now, she gave an answer the following month, in the following issue of the magazine. Now, the answer that she gave was shocking, because most of you thought that, yeah, that's the correct answer, easy, can we move on? What strategy? You don't have a strategy here. But then she said, you're wrong. There is a strategy, and what you're saying, your idea is wrong. Now, people were shocking, like, what? Yeah, like some of you, I can see some faces now. You'd be shocked. Why? I mean, it's correct. It doesn't matter if you change it to remain. Strictly speaking, it doesn't matter. In terms of mathematics, mathematically speaking, it doesn't matter. Well, she said, it does matter. And let me tell you something. If you switch your door, you will double your possibilities. You will double your chances. Now, I'm sure you're shocked, and not only you. Many professors, many mathematicians, physicists, they were shocked, and they wrote back to her, and they said, you crazy? You don't know basic probability? How come you don't see? You're so stupid. And it was very interesting, because it was a big revolution, and many people were fighting. Right. So, the answer is, yes, we have a strategy. But now my main point is, why? I mean, could you explain? Yes, I want you to understand why the strategy works. So, the strategy is that if you are presented with a game like this, the strategy is change the door. Now, why? Why it works? Here we are. So, the explanation is the following. You have 3 doors, 1, 2, and 3, and you have 1 car, so the probabilities, as Peter said, is 1 out of 3. 1 out of 3, so at the beginning, it doesn't matter which door you choose. This one, this one, this one. For the sake of the argument, let's pick this one. And let me stop there. Once you pick this one, you have 2 sides. The one that I pick, or you have 2 options. The one that I pick, and the doors that I didn't pick. Fine, obvious. So let me divide it into sides, because you can see it easier. So this is side A, the one that I pick, and this is side B. Now, what is the probability? What are the chances that the car are in my side, the side that I pick? This one, only 1. What are the probabilities that the car is in the side that I didn't pick? Or on the other option that, well, is here, which is 2 doors, so my probability is 2/3. So this is 1/3, and here is 2/3. You pick one, okay? Then I will continue. I just pick one, and I ask you to do. Listen, now think about in terms of size. The car is here, the probability that the car is here, I only have 1 door, is 1/3. The probability is in the other doors, is 2/3. Obvious. I have more probabilities here. Right. So I will continue. You open this door, you pick this door, I open number 2, and you see that in number 2 there is no car. So I will ask you now, do you want to keep or do you want to change? I can see some faces, some of you already discovered, right? There is no brainer now. Of course I want to change. Some of you will say, why? Well, it's so obvious. Look, think about sides. Do you want to be in this side or do you want to be in this side? In terms of sides, yeah, this side has more probabilities. In terms of side, this side has less probability. But look, you will say, teacher, but you were not talking about sides, you were talking about doors. Yes, but if you choose this side, you don't have 2 doors anymore. You only have 1 door because I already opened this one, right? So you still have here more possibilities than the car is, which is 2/3. You see? Okay. Interesting. Well, what I want you to do now, I hope you understood, right? What I want you to do now is, do you remember our previous class? In our previous class, we were discussing conditional probability. What I want you to do in 10 minutes, because it will take long, number 1, discuss with your partners, with your friends, if you understood each other the problem and try to explain. Probably one of you, hopefully one of you in the teams understood and try to explain. And number two, once you explain, I want you to think, after 5 minutes I will tell you, now I want you to write a proper proof. This is an argument, but it mathematically is not very strong. What I want you to write is a proof. Using our previous class yesterday, we were dealing with conditional probability. So I will just remind you the formula. The probability that the event A happens given B is equal the probability of A and B over the probability and B. So could you please, using the conditional probability, formalize this argument? What is the probability that I win given that I will change the door? What is the probability that I win given that choice? And then in our next session, I will prove it to you.